At the very outset, I would request our DGM to kindly welcome Professor Dube by presenting a flower bouquet. Our DGM to kindly deliver a welcome speech.
Respected Professor Shishir Kumar Dube Sahab, former Director IIT Kharagpur, Head of Center for Atmospheric Science, Dean, and many other positions in the IIT Delhi, Pro Chancellor of KIT University Bhubaneswar, Vice Chancellor of MIT University Jaipur, in various past years. Distinguished participants, delegates, for this special popular lecture being organized today as a part of celebration of the 150th year of establishment of IMD. It is a proud privilege for each of us to have Professor S.K. Dube among us on this auspicious occasion and to address us about the evolution of meteorological sciences, and especially with respect to the interaction between academia and the operational forecasters, taking an example of storm surge forecasting. Many youngsters, those who are present here, they might not be knowing the contribution of Professor S.K. Dube. It can be just simply told that the people who are dying due to cyclones in various parts of the globe, and number of deaths, if you just look at in the Bay of Bengal region, it was enormous. And the storm surge associated with the cyclone is called as the killer of the cyclone. The high tidal waves in association with the cyclones inundate suddenly the low-lying areas. And there was no such prediction system. But gradually, we came up with some kind of developments, statistical in nature, with the understanding of the various processes acting along the coasts. The based on the Jalesian scheme, the ghost nomogram was first introduced in India Meteorological Department to provide the height of storm surge at certain places along the coast. It was, you can say, a subjective, a semi-objective assessment of the storm surge depending upon the type of the track or the angle of approach of the track, the pressure drop at the center, and the type of topography along the coast. But these data were not available in digital format at that time, and Professor S.K. Dube Sahab is the first person who ventured into this area and developed a model which is popularly called as IIT Delhi Storm Surge Model, and which became operational at first in India Meteorological Department for Indian coast, and then it became operational for the various countries of the WMSK panel region. As we act as regional specialized meteorological center, we could provide this guidance to the other countries. And the first cyclone was Bijli cyclone, when it was hitting Bangladesh coast, we provided storm surge guidance based on the IIT Delhi model. Not only that, the people showed interest to have their own set of the modeling system. And it is Professor Dube who helped all the countries in this region for establishing the storm surge model for real-time operations to have an assessment of the storm surge expected when a cyclone is hitting their coasts. It is not only simply the storm surge, the contribution of Professor S.K. Dube with various interventions from time to time in the field of atmospheric science and oceanic sciences will be remembered forever, not only by India, but also all the world scientists working in this field. Many of us, sir, we have grown under your blessings. Those who have been associated with IIT Delhi and later on with IIT Kharagpur or with MET Jaipur or with KIT Bhubaneswar. Your contribution has led to the capacity building in terms of development of the systems, development of the systematic approaches, the standard operating procedures, and overall, the development of the human power, the manpower, human resources have been generated with all your interventions in the capacity of the professor, the administrator, the technocrat, and many more. So his work has been recognized worldwide, as I told you, including WMO and many other bodies. I think he is the best person to speak about the storm surge in this part of the globe. Now, of course, we have ventured into different versions, but each version has evolved considering the past versions. So we all will remember you, sir, for your contributions. And especially today, when we meet here, we are interacting with each other in a hybrid mode. Many people have joined online from various academic R&D institutes, Minister of Earth Sciences, various constituencies of the Minister of Earth Sciences, and also academia and R&D, especially the people in India Meteorological Department. Another point I just want to mention that most of you might be knowing, or if you do not know, that Professor Dube belonged to IMD. He started his career in IMD. So he's an IMDer. So he has the vast memory and experience while working with India Meteorological Department. He has been at the forefront in the establishment of the Center for Atmospheric Sciences. As you understood, we listened to Professor O.P. Sharma, how the three groups were constituted, one for the atmosphere, one for the ocean, one for the various types of interactions, etc. That was the beginning with the initiative of India Meteorological Department. Then the story went on, and now also the collaboration continues, and people are nominated by IMD and Minister of Earth Sciences to carry out the MTech programs in Center for Atmospheric Science, IIT Delhi. Not only that, there are many students, that means our employees, who are the students for their PhD degrees in IITs. So I am sure today's popular lecture by Professor Dube will motivate each of us, will ignite the young minds of the young scientists and engineers working in IMD and other establishments. It will also ensure the better collaboration between academia, R&D, and the operational forecasters to convert the science into services. And by that way, we can serve the society better by minimizing the loss of lives and properties, and by maximizing the informations on weather and climate to optimize the socio-economic activities, not only in the country, but also in the world. So with these few words, I extend a warm welcome to Professor S.K. Dube on behalf of India Meteorological Department and my personal behalf for this auspicious event. So thank you very much.
Of course, Professor Dube needs no introduction to meteorological community, but still, as a formality, I'll ask Anup to please introduce Professor S.K. Dube.
Thank you so much, sir. And a very good afternoon and namaskar to all of you. I'm Dr. Anup Kumar Misra from IMD New Delhi, and I'm very delighted to get an opportunity to introduce our speaker. We are honored to have Professor Shishir Kumar Dube with us, and sir has completed his PhD from Lucknow University in 1972. And he worked with India Meteorological Department between 1972 to 78. And subsequently, Professor Dube joined the faculty of IIT Delhi and worked at IIT Delhi in many capabilities, including head of Center for Atmospheric Science and Dean of Industrial Research and Development. Professor Dube was director of IIT Kharagpur during 2002 to 2007 and Pro-Chancellor of KIIT University, Bhubaneswar during 2008 to 2009 and Vice-Chancellor of Amity University during 2013 to 18. And Professor Dube has been the member of governing councils of number of institutes and universities. He served on many committees of WMO, and he has visited as expert of storm surge and wind waves to more than 40 countries. Next one. Professor Dube was elected as a Fellow of Indian National Academy of Engineering in 2004 and Fellow of Indian Geophysical Union in 2002, Fellow of Indian Meteorological Society in 2000, and Fellow of International Academy of Physical Sciences in 2007, and Fellow of Indian Academy of Mathematical Modeling and Simulation in 2009. He has received several honors and awards, including a National Award in Atmospheric Science and Technology, Ministry of Earth Sciences, Government of India in 2009. Kindly join me in welcoming Professor Dube.
Sir, now I request you to please deliver your lecture today. And
okay, Dr. Mahapatra and the young colleagues from the young and of course the senior colleagues from the India Meteorological Department. It is with great pleasure that I congratulate all of you on the occasion of 150th anniversary of the India Meteorological Department. I understand I was looking at the board which is there in the DG's office just before coming here. The first DG was Banford in 1875. So 1875 is where IMD was born, and as Dr. Mahapatra just mentioned, that I am IMDN, I joined IMD as a career. I started in 1972 in IMD. So maybe probably I will start my general talk from there only. If you see, since 72, when I joined IMD, although I left the IMD in 78, went somewhere else because of some other reason, not because the IMD didn't want me, but I didn't want I wanted some other place. So I left that thing. But then remained in continuous touch with IMD. And all problems, whatever I have been doing, I have been doing closely in association with the senior persons in India Meteorological Department. All persons I have worked with, R.K. P.K. Das and several other persons, but I will be coming to them and coming and probably telling in detail what work I did. So now if you see from 1972, so this is 224, how many years? 52 years.
52 years.
So 52 years association with IMD. So that is why I said the young scientist, because all of you
Yes.
association will really have the 52 years of association with IMD. And anywhere I go, I tell, and I will repeat it again here with Dr. Mahapatra being here, that whatever I have achieved in my academic life or administrative life, it is all because I have worked in IMD and I have learned certain things in IMD which I would not have been able to do it outside IMD. I tell you, sometimes I will tell you some smaller stories. Don't take it otherwise. Sometimes you may feel that I am criticizing IMD. No, I am not criticizing, I am just telling what happened to me. I think it was 72 only when I have joined. I have joined exactly on the 4th October 1972. And 4th October is my date of birth. So I didn't plan that thing, but it was when I was signing that thing, then it was the 4th October. Oh, today is my date of birth. So I have joined 4th October 1972. I think it was 15 days or 20 days after that. My boss was one assistant meteorologist, Changrani. If some of you know, I don't know. In hydrology, when I joined that thing, here the whichever office I was asked to report, I reported. They said, since you are PhD in hydrodynamics, the hydrology will be a better place for you. I also thought hydrology is a better place. I was appointed in the hydrology unit. About, I think, 15, 20 days, my boss gave one file to me, and I just kept it on table. And then afterwards, I kept it in the drawer of the file. I said, why this file is there, I couldn't understand. And then after 1 day or 2 days, the Mr. Sangrani, he was the probably my boss, he came to me and he said, Dr. Dube, where is the PUC? Then I said, PUC? I mean, what is this PUC? Then you don't know PUC? How did you join IMD without knowing PUC? I have known PUC, but subject was never taught in the I did my master's and PhD in Lucknow University. I don't know what is PUC. Then the PUC have given me the file. I mean, the file is called PUC. The file is here. So, but we have not written anything, no action taken or whatever action taken. पहले आप बताइए what is PUC? Then he told PUC is paper under consideration. So that's how I learned the PUC. And what happened, I think it is kind of the time when I was leaving that thing. So I was leaving IMD because I was declared the color blind in a promotion. So color blind, they didn't object my being in IMD, but then one person I knew, very senior person, Dr. Chaudhary, if some of you know, he was seismologist. So he met me one day and he told Dr. Dube, you leave the IMD as soon as possible, because even if you become senior and become eligible to a senior position, some of the junior person will be probably given the position, you will not be given. He said, I am a seismologist. So when it came to given the Director General of DGO's position, so I was told that you are a seismologist, you cannot be given a DGO post. So DGO post can be given only to a meteorologist. So that thing will happen to you. You are a colorblind. Why it should be given to a colorblind person when he is not eligible to become a meteorologist, he is not eligible to become a DG. Well, anyway, that was not the case. IIT, obviously, definitely, the IIT was a better place to work that thing. So I joined, that's how I joined the IIT. But before joining IIT, I worked here 72 to 78, several places I worked. I learned what is the PUC and what would be written in PUC. Somewhere, the file was sent to me, it was written AM on that one. So when I have to send it, that was AM, it has been sent in the forenoon. So in the afternoon, I was sending, I said PM. Again, this meteorologist came to me, but we want this file to go to PM. I said, well, you have said AM is there. So now this is afternoon, I said PM, I should write. So that's how I learned with difficulty. But then it was IMD where I was able to learn. I know other scientific departments also. I have been interacting and knew that thing, but IMD is the best scientific department where You can do the science if you want to do, you can do the administration, whatever you want to do, you are free to do it. You have all the research time. The library was very good when I have joined. The library is very good now. Earlier it used to be in the where you have that auditorium in the old building. That was the library. Not many of you probably know that was the library. Library used to remain open up to 7:30 or 8 o'clock in the evening at that time also. So anyway, I congratulate the IMD and all of you who are in IMD on the 150 years of the anniversary. Now, the thing is that normally I have never given a lecture. This is the first time I am giving a talk. I am sitting and by keeping some papers with me. Normally I have given this lecture only standing lecture. This is the first time I am giving this lecture. So I am not very comfortable in giving this lecture, but I will try to be comfortable to give lecture to you. Here I am not going to read everything. It is written here, but only thing that these are points I don't want to forget some point. That is why I have written these things here so that I don't forget what I have to tell. Now the most important thing is that the title, okay, title is not written there, but if you see, know the title of the talk is the Operational Forecasters - Academia Interaction, a case study of storm surges. Why I have written this thing, this is very important. By the academia interaction with the but what you are looking for, I've already told the title.
No, fine, sir. You can continue.
So let me tell you first about the academia. Then I will be coming to the IMG portion. In the academia, not many of you probably are, you may not be at all knowing when the first IIT was established. The first IIT was in IIT Kharagpur was the first IIT. Do you know? All of you know, isn't it? Do anybody doesn't know that first IIT was IIT Kharagpur? Well, not many people know. So anyway, so when the IIT was created, but later on we have been reading here and there in the literature that the IIT, Indian Institute of Technologies, came in picture. The vision of the Pandit Jawaharlal Nehru and this thing, but I still appreciate it was definitely the vision of those prime ministers who implemented it. But if you go to the history, you see that thing. IIT Kharagpur origin actually was not after the independence, it was before the independence. In 1945, a committee was formed in the leadership of Nalini Ranjan Sarkar, who was a very well-known academician and probably an engineer in the West Bengal, in the Bengal side at that time, it was Bengal only, or West Bengal, probably was already there, East Bengal. So, Narendra Sarkar, he recommended that why the committee was formed, this was done, because the government wanted that there should be some academic institutions which should interact with the industry in the different parts of the country, so that industry can grow. Because if industry is using some at that time software, that kind of thing were not there, but technology, I must use the word. If the industry is using some technology, it should be latest technology, not the obsolete technology. The thing by that, even the Tatas and all those things, they were very fond of importing the technology. And when you import the technology from anywhere, anything you import the technology, whether it is defense, whether it is meteorological science or any that thing, nobody will give you the latest one what they are doing. They will obviously give you some 2-3-year-old thing or the thing which they are not using now, or which is being very badly already given to other persons. So that's what is happening. So the British government, the then British government at that time, they thought that this committee should be there to look into how the industry can interact with the academia. So when it came to the Nalini Ranjan Sarkar and P.L. Bhatnagar, I'm saying, what was his name? Bhatnagar, what?
Shanti Swarup.
Shanti Swarup Bhatnagar. There was another PL Bhatnagar, I got confused. So Shanti Swarup Bhatnagar, all those things, they were members of that committee. They suggested that there should be 4 institutions in the country on the 4 sides, north, south, east, west. And the institution name should be Higher Technical Education. Institution name should be Eastern Higher Technical Education, Western Higher Technical Education, Southern, like that name should be there. So it was created, and the first IIT, or first higher technical education was created in Calcutta in Esplanade. There was, I think, some 7 or 10 acres of the land, and that land was created. Now they started looking for the director of the institute. So, sorry, I'm telling the IIT history, but because I will be joining that thing with IMD now.
Right.
So, they started looking for the director. Then Pandit Jawaharlal, by that time independence was, country was independent. So Prime Minister Jawaharlal Nehru was looking for the director. He found that Sir Gyan Singh Ghosh, who was the director of the Indian Institute of Science, Bangalore, was a chemistry person, but very well-known chemist. So उन्होंने उनको contact किया. He contacted Sir Gyan Singh Ghosh and asked whether would you like to go to Calcutta. We are starting a new institute, and you are holding the position of such a old institute of Tata Institute, Fundamental Institute of Research. But by the name KFR. KFR, would you like to go there? He said, yes, if you say, I will go there. Okay, he said, okay, go and join tomorrow. He came and joined, and he said, where is the institute? He was told, look here, this is the government building. You can demolish and make the classes. And he said, are we going to start a primary school? Or we are going to have a higher technological institute in 7 acres of the land? Then he immediately had to contact it. Nowadays, if you have to contact the minister, you have to first ask your secretary, so I contact the minister or not, otherwise action will be taken against you. You will directly talk to the minister. But at that time, this thing was not there. He immediately contacted the Prime Minister and told, look here, you have asked me to take over the institute. Here there is nothing. We cannot develop even one laboratory of the institute, the kind of the institute you are saying. Then he said, what we should do. Then he asked the Birla at that time, can you give the bits Mesra was there, bits Rati, can you give it to with a new name? Birla said, no, why we should change the name? Our institute is very well known in the country. So ultimately, who was the Bidhan Chandra Rai. Bidhan Chandra Rai was the chief minister of the West Bengal at that time. Bidhan Chandra Rai suggested that from here about 250 kilometers from here, there is a jail which is called the Hijili Jail. And the jail was actually built there at an isolated place to keep the our independent fighters to keep in isolation at those places, cells were made. So we said that jail is available. Why don't you take that whole area of the jail and start that thing? When Sir Gyan goes visited there and he found that that's a very good place. You must have seen that Mahapata jail. On the backside of the building. Did you see the jail? Hijili jail? A beautiful building. Still it is a beautiful building, which is maybe probably more than 100 years, 150 years or so, more than that old building. There it started. And the IIT, the main focus was IIT to interact with the industry. I'm sorry to say, at least in the last 50 years, there is hardly any kind of the product which I can say has been developed in the technology by this particular IIT and which is being used by the industry. The industries are very, if they, some technology IITs want to give that thing that is more expensive than getting the cheaper technology from the China. You go to China market, you get many things free, that kind of the cost of those things are there. So anyway, but it's still very important to have the interaction, academia and the industry. Now, when I joined IMD and again went back to IIT Delhi, I started looking into who is our industry. So somebody said Indian Air Force, Indian Navy. I said India Meteorological Department is our industry because our persons go there. They at that time, who was the director, I don't remember. The IT director was there in that meeting. IT director told, yes, you are right, Dr. Dube, because meteorology is a science, but the weather forecasting is a technology. So therefore, they are all those persons who are involved in the weather forecasting, they are doing the technology. And so technology, you should also participate because it is Indian Institute of Technology. Why are you there if you are getting project? So at that time, I think Dr. P.K. Das was the Director General of Observatories, Director General of Meteorology at that time. So Dr. P.K. Das took the proposal to the Planning Commission, and in the Planning Commission, it was approved to give the funding to the IIT Delhi and Indian Institute of Science, Bangalore, to start the Center for Atmospheric Sciences. And that is how interaction started. Maybe probably I didn't want to go into detail how it started because O.P. Sharma must have already, Professor O.P. Sharma must have already talked to that thing. So I wanted to avoid that thing. But I emphasized about the more IIT, while IIT also, some industry is missing the academia. So academia was also missing the industry. Now, with this one, actually, okay. So now it is 150 years of the IMD. So during this 150 years of the IMD, as I told, for the last 50 years, I have been in constant touch in different positions, in different committees and all those things. I have been there, so I am aware how the technology very fast has grown in the last 50 years. In fact, I will say, if you start looking after the 1980, the things have, especially the thing I was coming to the, besides the Asian summer monsoon, which was right from the beginning, probably the first director general of observatory when he came, maybe probably at that time also monsoon was a problem, and he must have talked about that thing and contributed about this thing. The another problem is the, which is the problem, I should say, one of the worst hazards which affect the coastal region is the storm surges associated with the severe tropical cyclones moving over continental shelf. So now this was the problem, and in fact, IMD, if I am not mistaken, the IMD came to existence in 1875 because of the cyclone in 1864, a cyclone which hit the Kontai region, or maybe Andhra Pradesh, in some regions was very severe cyclone, 1864, and then 1876, there was a cyclone which was very severe, and hundreds of thousands of people were killed. But since the data is very old, it is very difficult to think that how it was done. But the IMD was created, or IMD was established not only to look into the monsoon, but the main purpose was also the tropical cyclones, how to forecast the tropical cyclone, how to save the lives and the property of the people which get lost due to the tropical cyclones. So when I joined the IIT, in 1978. Up to 1978, I was in IMD. So then the IIT discussion was going on, what problem we should take it up. Then I said, 1977, that was a severe cyclonic storm, which was on 19th November 1977, Kerala cyclone. Kerala, Divi cyclone or Kerala cyclone, that will be being called. That was there. It killed about more than 10,000 people were killed, besides the loss of property and all those things. That was first in my mind. Then I said, okay, I would like to work on the tropical cyclone and forecasting. Anyway, it was agreed in by then. But let me, one small story I forgot to tell. I should have referred here, told that story to you. Without any aspersion on anybody, don't think that thing. when I was in IMD, I was sent for the training to training IIT of the IMD. I was sent for training to IMD Pune. So during the training, beside me, I was the first person. You will laugh when I tell when I was appointed or when I was being considered for the appointment by UPSC. I looked into before that. I looked into the dictionary to find out what is meteorology. I didn't know meteorology after doing masters also in the so it relates to something, weather forecast or something like that. Anyway, I prepared accordingly. But anyway, when I was selected for this one, and went for training, I went for training. So in my training, there were many senior meteorologists like Patnaik and other persons who had great experience of those things. I was a person who didn't know at that time what is the meteorology means actually. So, but somehow or other, I don't know how it happened. It happened that I secured the highest marks, not only in the practical forecasting, but also in the theoretical, all these subjects, including from physical meteorology to the numerical weather forecasting. So Dr. Day and others who were also with me, they were very upset. They said, Dr. Dube, what will do? So then one of the teachers who was teaching, Dr. Rao, he was the director of the training session. Many Rao, it is very difficult to say which Rao I am referring. So he told in the class, he came to the class, Dr. Dube has got the maximum marks. They used to say, secured maximum marks in the batch. So he has secured the maximum marks in the batch, not only in the practical forecasting, but not only in the theory, but altogether everywhere he is number one. That means why he is number one? Because whatever we wanted, he exactly answered that thing. How did you do this thing? I told her I did it because whatever was being taught in the class, I will immediately go in the same day in the evening. I will prepare the note in detail, and if something is missing, I will consult the book and find out. At that time, Google was not there. You have to consult the books only. So consult the book and find out what it means, and I put in. So my notes became so popular that I left I was in 121st batch. I still remember the batch number. But the next batch of people when came, they contacted me, can I get a copy of your notes? Maybe they were told. So anyway, so that result that I secured the highest marks in the batch was circulated to all the officers in the IMD. And Dr. P.K. Das was at that time the Deputy Director General and was also looking after the hydrology unit. So he has seen that thing. He has after seeing that thing, he called me. Immediately, telephone came. My boss told me, look here, Dr. P.K. Das is want to meet you. And who is P.K. Das? Then he's a Deputy Director General. I don't know him. I don't know. So then, okay, come with me. So he had taken with me to Dr. P.K. Das, and I went there, as I used to do in the academic. Whether I am meeting the Vice Chancellor from there, I will go there and have the seat. I went there and have taken the seat and sit down, and my boss, Abhi, was standing still. I felt very upset. I said, but he is standing anyway. He remained standing. P.K. discussed with me. He said, I want to give you one problem. And that problem relates to the storm surge in the Bay of Bengal. I have done some study, but nobody is doing any numerical modeling. So I thought that you have PhD in hydrodynamics, so you will be able to do it. So I'm giving you this problem. Go and do it. Tell me if the some water is released at the Dhaka, how much time it will take to reach to the Meghna estuary and in the head Bay of Bengal. Okay, so he has given some. I didn't know the programming also very well. So he attached the Datta Chabra. When Mr. Chabra was there, he attached Chabra. Chabra helped him to do the computer programming, but we did the computer programming. Then it had happened 1 or 2 days only. Suddenly I get a telephone, when the telephone was not at my place. somebody else, भाई डॉक्टर पीके दास के ऑफिस से फोन है। मैं कहा मैम यस बताइए कौन बोल रहा है। मैं कहा मैं पीके दास बोल रहा हूँ। हाँ क्या हुआ, रिजल्ट आ गया? मैंने कहा अभी तो सिंटेक्स एरर करेक्ट कर रहे हैं। and I submit the program. After the end of the day, I get the 2 pages saying the syntax error. So then I correct on the card. There used to be card. I don't know whether you have used this error. Mahapata, no.
Yes, sir.
Card.
Yes.
So the card means you have to correct in the card syntax error and submit the cards again and get the result next day. He said, no, why is it taking time? So whom should I talk? So I talk to Sabra. Why it is your results are not coming? फिर 2 दिन के बाद फिर बुलाया। मैं बता रहा हूँ कितना मुश्किल होता था काम करना, इंटरेक्ट करना विद दी ऑपरेशनल एंड लाइक ही वाज ए एकेडमिक पर्सन एंड ऑपरेशनल पर्सन बोथ टीचर दैट ही कॉल्ड मी ही and then I had some results I wanted to show to him how the water travels from the Dhaka to Meghna SC. So then he asked, what is the distance between the end of the Meghna SC and the
You can come. Okay.
So I continue.
Yeah, you can continue.
So he asked me what is the distance between the Dhaka and this end of the Meghna Estuary. I said 120 miles. And then I said 120 kilometers. ये 2 चीज़ें मैंने कही थी। अब मैं जैसे हिंदी में तुमको बदलने जा रहा हूँ, जिसमें हमारे जो मित्र हैं वो लोग नहीं जान पाए हम क्या कह रहे हैं। उन्होंने उठाया कागज, हमारे सारे कागज बाहर फेंक दिए और कहा कि निकल जाइए यहाँ से, बाहर निकलिए। जब यहाँ आते हैं तो आपको ये नहीं मालूम किलोमीटर है कि मील है। आप कह रहे हैं 100 मील, फिर कहते हैं 100 किलोमीटर। हमने कागज उठाया, अपना चला आया जाए एडमिशन से, अपना आके बैठ गया। वो कागज अपने ड्रॉर में बंद कर दिया, दोबारा खोल के देखा नहीं। 1 हफ्ते के बाद उनका फ़ोन आया और उन्होंने कहा कि आइए मिलने आइए। तो मैं फिर मांगा रहे हैं, उन्होंने फिर दिया, फिर चले गए। तो कह रहे हम सब सॉरी डॉक्टर दुबे, दिस हैपन, बट एक्चुअली दिस इज फॉर योर I'm a well-wisher. I got a PhD in hydrodynamics and joined here in India Meteorological Department. I want that you should go. That's why I did it. So well, that was the kind of the interaction with the academia of the and that one. So now, since the other speakers are here, I have written many things which will be circulated by Dr. Anup will circulate to you. Maybe later on you will know more. But I would like to just say that thing, how the interaction started with my interaction started in the field of the storm cell with the other areas. Initially, I did my storm cell modeling in the University of Reading in England. Some of you know the University of Reading, so it's a good place, University of Reading, to work. So I worked there for several years. So I worked on the storm cell modeling, and which I came and implemented for the Bay of Bengal and the Arabian Sea. So when I implemented it, I did some results. And so wanted to show to the then director of this cyclone program of the IMD. He said, look here, Dr. Dube, this is all your academic exercise. Go on doing your academic exercise. Don't disturb us. We don't want any collaboration or any interaction with you. You can go and continue doing your own work. So it was very difficult to even continue or interact with the operational people because they said you can do your own work. The thing started actually, I'm telling you, it's not because Dr. Mahapatra is here. If he would not have been here, I would have told you exactly the same thing. I think it was 1995 and 1990, after 1999,
Yes.
I met you in Bhubaneswar.
Yes.
Yeah. I met one young meteorologist who was in charge of the Bhubaneswar Met Office, and that was Dr. Mrityunjay Mahapatra. I met him there in the Bhubaneswar. There was some discussion was going on because I was organizing the top met meeting in the Bhubaneswar, for which what should be the who should be invited, all those things. Several hot discussions was going on. I told Dr. Mohanty, who was there with me, I told Mohanty, this boy who is working here, the young boy, he will be one day Director General. We will see. How many years back? Maybe 25 or 30 years.
25 years.
25 years back, I forecasted. 2002, yes, it was 2002. I was trying to
17
remember.
years.
Yes. 2002, it was then Naveen Patnaik came to India. I was trying to remember. So I told her this thing about will be one day DG. Monkey said, "Kaise pata bhai aapko? How do you know he will be DG?" I said, "Well, the person normally when you start discussing, you say you are from IIT. The other person says, okay, whatever IIT person is saying, maybe he is right. He will not argue. But then he can ask the question that thing means this is not right, this is not right. It means that he is the person who has knowledge and he will definitely become that you will see." And I told him also, later on I told that you will be one day go up to the highest position in the department. So it was Dr. Mahapatra. Because of that, I learned many things what the operational meteorologist want. Because before that, I was only an academician. I was doing good research, a good journal I was publishing, good impact factor. So I was very happy that everything going on very well. As far as I'm a professor in the IIT, so this is good. But then it was Dr. Mahapatra who said, look here, we do not want that you are saying the storm surge will be 3 meters. Maybe it will be 3 meters, but what area it will be inundated, what area you would like us to evacuate the people, whether the people should be evacuated horizontally or vertically, all that kind of the question Mahapatra put in. So then we could understand what kind of the forecast he wanted. He wanted that kind of the forecast, how much not only the height of the storm surge, but also how much area is likely to be inundated due to this type of the storm surge. So anyway, it's a long story. I don't want to go into detail. So he came to here RSMC, Regional Specialized Meteorological Center, with 1972 it started, isn't it?
Yes,
RSMC.
1973.
73 it was started, and I think probably sometime in 1980s it also tropical cyclone, it became specific to tropical cyclone.
Yes, sir. RSMC, 1988.
Yes, 1988. So it became that thing, and I have been giving lectures here and there. I went to Sri Lanka, and then later on I was invited to a meeting in some place in the Thailand, northern place. I don't remember the city's name, which is in the north actually. So there it was, the meeting was there. So I made presentation. In that presentation, fortunately, the Dr. Abe, Mr. Abe, who was the head of the tropical cyclone program in the WMO, he was present, and besides Dr. Abe, the Nanette Lombarda, she was also there in that meeting. So they attended my complete presentation, and I showed them how a storm surge model can be implemented as a standalone model on a PC, which is not a very high configuration PC, which were not available in many countries in the North Indian Ocean, that kind of computation facility, how it can be implemented and what results you can get it and how useful its result will be. So they appear to be very happy. Mr. Abe appreciated at the end of the meeting. He said, Dr. Dube, this is very important because there are many countries in the North Indian Ocean, countries which even have not used the computer today, and so they will not be able to do it. So what we should do? I said, I don't know what we should do. They should get some training. We will provide the training. He said, I said, look here, we will provide the training, but the training should be organized through RSMC, New Delhi, IIT Delhi together. Then only it will be successful. So they agreed, and in 2001 was the first, the WMO agreed to the thing, and they said every year the 2 operational meteorologists from these countries, North Indian Ocean countries, I will be sending to IIT Delhi and the RSMC in New Delhi to interact with the operational forecasters as well as the academicians and bring the model and implement it here. for our operational use. So then the first batch was in 2001 was from Sri Lanka. 2 meteorologists came from Sri Lanka. That it was a 2 weeks training. We provided 2 weeks training. They were very happy. They went and implemented the model very easily because we implemented the model on their laptop itself. A simple model we developed. We didn't develop a very complicated model, which takes a long time, a lot space and that kind of thing. So they submitted the report to WMO. WMO was very happy. So since 2001 to 2014, this thing continued. After 2014, probably there were some changes in the WMO, and because of these changes, the the training program is suspended. That probably doesn't exist now in the STAM subject. But anyway,
That is going on in RSMC training.
that's going on in RSMC. Very good. So, but whenever any scientist comes to RSMC, I remember they try to contact S.K. Dube, where is S.K. Dube? But you know, so I feel very happy. Not that thing that I want that people should remember me, but if a teacher becomes happy, if a student remembers him, because so, I consider when a student, I remember one of the talk when it was going on, the Myanmar talk on your online talk was going on, one of the Myanmar meteorologists, she wanted to, she said, but continuously sending message, I want to talk to my teacher, Professor S.K. Dube.
Yes.
So I went very happy. So well, so like this it happened. Now many things we did with IMD and the implemented model. I will not go into the details of those things as I mentioned. The other persons also here, and I have taken probably more time than what was expected for me to take. So let me come to this last point. Well, since 2009, actually RSMC also started using the IIT model to provide the guidelines to these things.
Weekly cycle.
The last page is what I have suggesting in the future. But okay, I maybe probably I will like to close it here. I have already talked too much. Well, I am personally grateful to the PCP and PCP of WMO and RFMC New Delhi for attaching the operational meteorologists from the North Indian Ocean countries to the IIT Delhi for undergoing the training in the storm site. So that was very important. And in this process, it is not that they have learned from the IIT. We have learned many things from the operational meteorologists, what they need in the operational and how we can provide that kind of thing, what they need. At the end, I would like to say that to the RSMC and the IMD, let us continue working together closely for the better life of our people and the better future of the Viksit Bharat in the Amrit Kaal. धन्यवाद, नमस्कार, जय हिंद. Probably I have taken some of the time.
Or any question?
Yeah, so now the floor is open for the questions here. So,
That's my button.
Yes. Anyone, any youngsters?
As I mentioned, this was the first time where I'm giving the lecture sitting because they have problem. Otherwise, I've never felt very comfortable giving lecture while sitting. When I'm standing and walking, I can give a better probably. So maybe probably you have understood what is being done, or you have not understood, don't worry. So
Dr. Vijay wants to.
Yeah, Professor Dube, I don't know whether you remember me, but probably not. 1996, you were at Andhra University at TropMet,
yes.
and I was taking you on the scooter on my scooter to Outgate to get something for you. I hope you remember that. But the point was, on the way, we were talking about
something that you mentioned, I could understand that thing. That's okay, yes.
So on the way to the Outgate, where the beach road was close to that, and you were talking to me about the storm surge modeling and how important it was. And then I asked you whether AdCirc or the Slosh, those are the popular models in the West, were they designed to deal with the bathymetry of Bay of Bengal and Arabian Sea? And you gave a very good answer, actually. I don't remember exactly what you said, but you said you have to design your own models to understand the local conditions much better than adopting somebody's models from outside. So I just wanted to pick your brain again on how true it is in the new modern era of sharing knowledge across different countries.
Well, thanks very much for reminding me of these things. Yes, I remember briefly these talks that I had with you, and for what I was asked you to go to the gate with me. So anyway,
For your pawn. We went there for your pawn. I'm just telling the secret.
Well, we could understand. So anyway, I missed one very important point. Because one of the program, the WMO, they started the program by the coastal inundation program. I think they started, and I was one of the members right from the beginning of the coastal inundation program. This was started, and we also wanted to work. But then the IIT Delhi, and I'm very happy to introduce Dr. K.L.N. Murthy. Here, K.L.N. Murthy, and he is my student. He did PhD with me.
Yeah.
So he worked on the AdCirc model and modified the AdCirc model in such a way so that it is applicable to the Bay of Bengal and Arabian Sea, including all the rivers and estuaries and inlets which are joining the Bay of Bengal and for the Arabian Sea also. And he did PhD on this using the AdCirc model, and now he is with the India Meteorological Department. So this is a kind of the academia and industry interaction. Very good. So AdCirc model, so we are using the AdCirc model because we didn't, well, the model which is being used still, I will not say it's a complete thing, because there are two future things which I wanted to mention. Can you mention it now?
Yes.
Okay. The two future things, especially K.L.N. Murthy for you, because you are looking after the storm surge in the IMD, the long story actually was long back, I don't know how many years back, I mentioned that we will be doing that thing, but we have not been able to do the probabilistic storm surge forecast. There is probabilistic cyclone forecast is there. So you can very easily use all the parameters that you need for the storm surge forecasting, and you can prepare the probabilistic storm surge forecast. Because in the event of the climate change, which is the uncertainty, you do not know when the climate change, whether the wind will increase by 5% or 11% or 20%, nothing is known. Somebody works with 20%, somebody is 11%. So when you are doing the probabilistic forecast, that will be very useful to the operational meteorologist. If I feel. The second thing is your inundation model, which you are using the AdCirc model. The AdCirc model gives the inundation, the water coming from the sea to the land side, to the estuaries, and then over the shallow lands, all those things. But the actually it should be hydrometeorological model should be joined or coupled with this AdCirc model, so that whatever the precipitation or rainfall is taking place, through the rainfall, whatever water is coming towards the sea, that also interacts together, both storm surge as well as the rainfall. So hydrology is still not there in the AdCirc, if I understand.
Thank you.
Any other questions? Sorry if it was a long answer.
That's fine.
Good answer.
Anyone else? Any online? Please check online. Or not?
All participants are requested to ask the questions if they have.
Take the chat box.
Nothing is there in chat box.
Now it's let us thank Professor S.K. Dube for now it's our time to express our gratitude. Sir, Dube sab jayenge, sir.
Yes.
So I would request our DGM to kindly felicitate him with a shawl and a memento.
Really, really hot. Not very well to little difficulty in standing.
No, Professor.
And it will be, yes, sir, I am late.
Yes, sir.
Inshallah. I'm not feeling well, so can I leave with permission?
What's that?
I want to leave.
That's a good escape. So it's an honor to meet you.
I'm
sir.
not feeling very well. Some health problem.
Yeah, I understand.
So it's really आज हमारे पास भी शब्द नहीं है. We don't have actually words to express our thanks and gratitude to Professor S.K. Dube, despite of
एज तो ज्यादा नहीं है, ये प्रॉब्लम ज्यादा हो गई है। एक अभी हवा में 22 year old minus 100. Okay.
Murthy.
Sit for something. You want to sit for something?
Yeah, I will.
Okay.
I would like to bath a little bit and. Okay. Started.
Something behind her? Yes, that's that. Oh, here it is. Over there. Okay. That's it, right?
Narrate the story to you.
That's all.
We got here about 15 minutes ago, so we heard a good part of it.
Once again, we welcome all of you for another lecture, and we welcome Dr. Michael R. Farrar for and we are very thankful to him for kindly sparing the time for delivering this lecture to our officers here. At very outset, again, I will request our DGM to kindly welcome Dr. Michael with a flower bouquet. With a bouquet of flowers.
It's a problem. Yeah, yes.
Thank you. I request our DGM to kindly welcome, deliver a welcome speech for this lecture.
Dear Dr. Michael Farrar, Director, National Center for Environmental Prediction, USA, distinguished delegates and participants for this popular lecture being organized by India Meteorological Department to commemorate 150 years of the establishment. Dear Prasadji, Director, National Center for Meteorological Forecasting, my dear friends from USA, and distinguished ladies and gentlemen joining online and offline. As all of us know that India Meteorological Department was established on 15th January 1875 and will be completing 150 years on 15th January 2025. So to mark this occasion, we are organizing among various activities a series of popular lectures. And today, among us, we have the director and chef who does not need introductions, as NCEF is the buzzword for each and every meteorological community. As and when we think of carrying out any research worldwide, people immediately go to NCEF and carry analysis. So that is the contribution of USA, contribution of NCEF, and the organization is headed by Dr. Farrar, and who is present here with us. I feel it is a momentous occasion, proud occasions, and we are most privileged to have this occasion. And more further, he has agreed to deliver a talk addressing the young minds present here and online. And I am sure with his talk, the young minds will be ignited to take up the research problems, address the requirement of the globe, and we can contribute for the well-being of the society. As all of us know, the relationship between USA and India has been ever growing. Since when, I cannot say, but as I dealt with cyclone forecasting, I came to know about the various experiments carried out over the Bay of Bengal and Arabian Sea. Since very beginning, be it the IOE in 1960s, or be it the MONEX in 1979, or be it the first satellite launched by USA, TIROS-1, in April 1960. India, as a proud country, got a receiver donated by USA, which was established in Kolaba of Mumbai. And from December 1963 on real time, we could get the satellite picture of Bay of Bengal and Arabian Sea. It helped us to understand the monsoon, to understand the cyclones, and to avoid the missing of the cyclones. But however, further, the process went on, collaborations went on. We could get geostationary satellites in 1974. Then we came up with our own satellites, and we got our own understanding, which is renewed every time. The people have exchanged their views and ideas by the mutual respect and mutual sharing. Many scientists and engineers from India have visited USA, and from USA also there have been the visit of the distinguished scientists and engineers. So that has not only enabled to understand each of us, it has also enabled to introduce the new mechanism for observations, monitoring, analysis, forecasting, and early warning generations and disseminations. And we both the countries have worked together to serve not only each other, but also the entire globe. And especially when you talk of Bay of Bengal region, Arabian Sea region, which is a data-first region, where you depend more or less on the remotely sensed data, where you depend more or less the theoretical research, where you depend more or less to develop such a technology which could be low cost, which could be easily accessible, which could be easily utilized by the common people in this part of the globe. And this collaboration therefore has helped not only India, but also the South Asia, Southeast Asia, Middle East, the island nations in this part of the globe. The outcome has been the improvement in weather forecasting tools and technology, the improvement in observational systems and modeling techniques, and capacity building over the region. And finally, we have been able to minimize the loss of lives in this region because of all these developments. So therefore, on my personal behalf and on behalf of India Meteorological Department, we express our thanks and gratitude for all overall collaborations, cooperations between the two countries, and specifically with respect to the field of meteorology and allied sciences.
Right.
So today we are here to listen from horse's mouth about the current status of the science of meteorology globally, and especially the role of NSAF and NOAA for enhancing it further. It becomes more appropriate for us as we have completed 150 years, people are thinking that we are the old generations. But I can assure you, the people sitting here, almost majority of them are below 40 years. So therefore, it is still young India and India Meteorological Department, even though we have entered into 150th year of our establishment. So they are all very promising, and they can contribute, and they can listen to you, and they can be guided, motivated by your speech, by your ideas, by your thought and inspirations. So I'm sure that as a community, beyond the boundary, we can work, we can prove to the society our worth, and hence further minimize the loss of life and optimize the information on socioeconomic conditions with the mainstreaming of weather and climate informations. So I, on behalf of all of you, once again, thank Dr. Farrar, all our US colleagues for making it possible, and also Dr. Prasadji for taking the initiative to organize this event of 30 years of NWP. It is a golden opportunity. We'll remember you forever for visiting India Meteorological Department on its 150th year. So thank you very much.
Well, thank you very much, Dr. Malhotra. I'm very honored to be here.
Thank you.
Oh, we're taking
Yeah.
what's that?
And that's nice of you.
Thank you, sir. Now
Sorry.
I'll request Anup to briefly introduce our speaker.
Thank you so much, sir, for giving me this opportunity to introduce our speaker to the audience. We are honored to have Dr. Michael Farrar with us. Dr. Michael Farrar completed his PhD from FSU, and at present, he is the director of National Center for Environmental Prediction, NCEP. As director, Dr. Farrar oversees the planning, science and technology, and operational responsibilities related to NCEP's 9 centers, which include the National Hurricane Center, Storm Prediction Center, Weather Prediction Center, Ocean Prediction Center, Climate Prediction Center, Aviation Weather Center, Space Weather Prediction Center, Environmental Modeling Center, and NCEP Central Operations. In his previous role, Dr. Farrar served as Chief Scientist for Weather Operations for US Air Force, where he was primary science advisor to the USF Director of Weather and Coordinated Science and Technology activities related to weather operations. In 2017-18, he was the Senior Vice President and Chief Operating Officer of University Corporation of Atmospheric Research, that is UCAR. Before his time with UCAR, he was the Director of EMC and the Director of NWS Meteorological Development Laboratory, MDL. He also served as Acting Deputy Director of NOAA Office of Oceanic and Atmospheric Research, OR. Prior to his work with NOAA, Dr. Farrar was the Vice President of Strategic and Business Development for Science and Technology Corporation, STC. He began his career as uniformed USF meteorologist, where he served for 24 years in several leadership positions in forecast, operations, scientific developments, program management, training, budgeting, planning, policy, and collaboration with US and international partners. So please join me in welcoming Dr. Farrar.
Now we request today's speaker, Dr. Michael Farrar, to kindly deliver his lecture. So over to you, sir.
Thank you very much. And as I was prematurely getting ready to starting to say, so thank you for correcting. It's my honor to be here. This will be about 40, almost 40 years in the weather business. I'll be retiring from federal service next month and moving on to private sector before I fully retire, but it has been, it means a lot to me to be able to come here before I retire from NCEP, because the cooperation I've had with our international partners over the years and the special relationship we have with you know, the National Center for Medium Range Weather Forecasting, as well as IMD, has been very, very important. We've been very mutually beneficial to both nations. And it's just really an honor for me to be here to celebrate your 150th year at IMD and 30 years of NWP there at the National Center. So with that, with a wonderful preamble by Dr. Mohambatra and an incredible talk. I missed the first part from Professor Dube. I'll just try to keep up. And I hope that my main goal is that you don't regret leaving with Dr. Dube when you had the chance. But I will do my best to make this worth your time. It's my honor to talk to you today, and I'm really going to talk about, if you go to the next slide, we'll talk about three main things. So I'll give you a little bit of an overview of my parent organization, the National Weather Service, and what's changing there, what the priorities and mission and goals are. Then I'll spend the majority talking about NCEP and how it kind of fits in. And then only one slide at the end about future plans and challenges, but I know there's a lot of commonality, things that our challenges are very similar to yours. And I hope that maybe in the question and answer part, we can talk a bit about that. And I'd like to hear from you, and myself and Vijay and Avichal could talk to you about how we're addressing future challenges. So with that, go ahead, next. Again. So the mission of the National Weather Service is, and I'm sure this will sound familiar to you here, is we're providing weather, water, and climate data, forecasts, warnings, and impact-based decision support services, or IDSS. And the purpose is to protect life and property for our citizens, as well as enhance our national economy. And then our vision for the future is about a 10-year-old concept called Weather Radiation, which I'm sure you all heard of because it actually has made its way to the WMO with the Weather Radiations plural. So that's really getting society prepared to be able to prepare and respond to extreme weather, water, and climate events. That's something you all can very much identify with for what happens here in India as well. I'll talk a little bit about IDSS in a second. That's not an new concept, but it's been elevated in importance to what we do in the Weather Service. Next slide, please. So one of my predecessors, Dr. Louis Uccellini, who visited you here, I think, a couple of times during his many years as NCEP director, this is one of his favorite quotes from an article well, I guess that's 31 years ago from Professor Alan Murphy that talks about that really he claims that forecasts themselves do not possess any intrinsic value. They acquire their value through their ability to influence decisions made by the users of the forecast, whether that be the general public or sophisticated users like aviation or power sector, etc. Next slide. So really, and the basic concept is that we take our forecast and warnings, we connect it to the decision-making process of our stakeholders, and they get the most value and being able to apply that information. So you all do that a lot. I was able to go up and see your operations floor with all the different functions. We have a very similar thing in the United States. So this has taken on an enhanced role, this IDSS concept, because over time our models are getting better and our ability for our human forecasters to add value to the models is getting more challenging. We still do add value, but the resources required for the human forecasters is probably not what it used to be. Their ability to add value is more efficient now. So we want to take that excess capacity and have it focused on embedding and being very close with our stakeholders to help them make use of the forecast better. Next slide, please. So our new director is not that new anymore. He's 2 years in. Is Ken Graham. He used to be the director of the National Hurricane Center. So he used to work at NCEP, and now he's running the National Weather Service. So his three priorities are under this umbrella of people and infrastructure and future. And I think you can identify with this here. is that he wants to make, we have challenges with retention, with hiring, with aging workforce. Many of our workforce came on in the 90s when we had the National Weather Service modernization. So we have a wave of retirements that are happening now. So it's important for us to recruit replacements and the next generation. But the next generation doesn't have the same values or way of thinking that the 30 years ago did. So we're having to evolve. But we also want to retain our good people. So we're trying to institute policies and programs that make it easier for people to balance their professional life and their personal life. So we don't have them leave to go off to take better jobs. So that's a big effort for us on the people side. On the infrastructure side, I think all governments across the world have this problem. Infrastructure is aging, whether it's buildings or systems or programs, you name it. We have not, keeping up with inflation with our budgets has been hard. So sometimes our infrastructure has had to take a second priority. And so we have things we need to replace. One of the most important ones is our NextRad Doppler weather program, our network that was put in the 1990s. We've already had 2 service level, they call it service level extension program, which is repairing and modernizing. But you can only do that so many times before you have to do a full replacement. Well, we're almost there. So that's one of our biggest programs now, is planning for the next generation of our radar. And then finally, this future aspect is not just taking care of the people and modernizing the infrastructure, but what do we want the National Weather Service to be in 5 and 10 and 20 years? And there's a lot of things we want to do, and we'll talk about that a little bit more in a second. But in reality, what our director is doing is he really wants to focus on kind of reorganizing the way that we do business, have our forecasters in the local offices be more efficient on just putting out the forecast, and then have more of them deliver that decision support services to our partners. So that's going to be a big change in culture and the way we do business. Go ahead, next slide. So I don't want to get into all this. He's just organized this around a bunch of small programs. And so some on the short term, some in the medium term, 2 to 5 years, and then some 5 years and beyond on the long term and strategic. So we're working on a bunch of these now. Several affect INSEP, for example, on the left-hand side. We have our INSEP version of AWIPS. AWIPS is just our forecaster interface. And then the local offices have a different version. Making those two work together is a software project that has taken over 15 years and we're still not done. So that's a really big important one, because we're going to take all that information and port it to the cloud. So we'll be able to be more mobile. Our workforce will be more mobile. We'll be able to take our workstations from our weather forecast offices and go into an emergency management agency or another key partner and do our jobs there in event of a catastrophe or other big event. I won't belabor these. It's just a lot of, you can get a lot of these slides afterwards to review. If you have any questions on any of these specific ones, you let me know. We can give you an answer back. Go ahead and get to the next slide. So we also developed our own strategic plan inside of INSEP, and we call it a strategic implementation plan because it's really more short term. We want to be implementing things and a lot of these are very similar. We organized around also our people and work culture. We want to improve our operational workflows and make those a bit more efficient and more responsive to new technology. On the science and technology side, we're talking about bringing in, modernizing our technology and bringing in new equipment, as well as continuing to focus on scientific development. And then finally, global partnerships are very, very important to us. And so that's not only the bilateral like we're doing now between India and the US, but also multilateral in places like the WMO or other regional organizational participation. This is what's important to us. So these are the things that we're trying to do. This is kind of our umbrella framework. We have lots of little projects that are buried under here that I'm not going to get into. This is just what's important to us at INSEP for the future. Go ahead, next slide, please. So we'll go ahead and talk now about how INSEP fits in with our parent organization. So I'll show you a few organizational charts just to illustrate how we're organized. It's a little different than you have here. But if you go to the next slide, if you think of NOAA, which is the National Oceanographic and Atmospheric Administration, that's sort of like your Ministry of Earth Science, Environmental Science, excuse me. and it captures all the big things like satellites and ocean service. And so there are 6 of those offices, and they're listed on the right. The National Weather Service is the one that INSEP falls underneath. But we have several of the other services. So think about that as your MOEs. Not exactly the same, but fairly similar. And so if you go down to the next slide, the National Weather Service itself. Next slide, please. There you go. National Weather Service itself is organized around operations on the left, systems, and then kind of the headquarters functions. So you look on the left-hand side, those first 3 are all our operational offices. So we have, we're kind of a combination of national centers and local offices. So the one national center that doesn't belong to INSEP is the Office of Water Prediction of the National Water Center. That's the hydrology part. There's some political and budgetary and scientific and systems reasons that to merge under INSEP, it's too complicated now. We may do that later. No, go ahead, next slide. Again. So how are our local offices? If you look at the top left-hand corner, those are our river forecast centers. These are our hydrological regions. And these are the only ones that are organized based on science. Everything else is more practical. Those boundaries are river basins. So there's a natural barrier between those. So those are our major river basins in the US. And there's a separate one up in Alaska, which of course is northwest up in Canada. Those provide river forecast and stream flow observations and predictions. On the right are our 122 local offices. Those were put there back in the 90s when the new NextRad weather network went in. Prior to this, there were like several hundred offices, and they were much smaller. So there was some consolidation that happened, and they did that at the radar sites. Back then, that was the reason. That was 30-something years ago. We're still operating the same way 30 years later. That's why our new director wants us to change the way we do things a little bit to modernize. The bottom right-hand corner, we do have a special relationship with the Federal Aviation Administration, the FAA. So we have a small team of meteorologists that are inside the regional centers for air traffic control. Those are not part of INSEP, but those are the meteorologists that serve a very special function. And then finally, the 9 national centers are INSEP are at the bottom, and that's what we'll talk to you starting with the next slide. So there are 9 centers. The ones listed in red are located in different parts of the country. All the other 5, the ones in black text, those are all in Maryland, where VJ and Avichal and I work. I'll have a slide on each of those. So I'll just talk to you briefly about what each of those centers do. And then we can talk about their challenges and plans for the future. So really our vision is to be the trusted source for environmental predictions all the way from the sun to the sea. So the sun, of course, being for the Space Weather Prediction Center, and the sea, the Ocean Prediction Center, where Avichal now works. And so we do that through executing our mission of delivering, national and global operational weather, water, and climate products. And then we really provide essential for protecting the life and property, and of course the economic aspects as well. Next slide, please. So here's an overview of INSEP, a few slides first to kind of give you some commonalities between the centers, and then we'll talk about each center very briefly. Next slide. This is a nice new building. It's not new anymore. This is the one, probably 12, 15 years old, but it's up in College Park, Maryland. It's on the edge of the University of Maryland campus. So in that facility, we have 5 of the national centers that work for INSEP. We also have some of our satellite services there. We have a piece of one of our NOAA research labs is in there. And we have a lot of our central IT stuff there too. Not the supercomputer. That's hosted elsewhere, and I'll talk about that in a minute. Next slide. So what's the role of INSEP? We provide kind of the national level foundation for that impact-based decision support services. There's special relationships out at the local offices they have with their local customers, but we try to set the stage at the national level through our centers. We also serve as an innovation hub. Most, if not most, of our centers have a test bed that goes with it. And those test beds are able to bring in our operational meteorologists and development meteorologists from INSEP centers, with our partners at the research labs, with academia, with external partners. even with the broadcast media, the TV meteorologists will sometimes join us when we do experiments to test out new concepts, to try out new products. And we do this a couple of times a year, at least in all of our centers. It really helps keep us connected, but from the science to the operations, as well as connected to our stakeholders and users. Next slide. So the strengths that we have at the national centers, I like to use the analogy of medicine. The local offices are kind of like your general practitioner, your family doctor. They have to know a little bit about everything, and they have to serve everybody in their community. Our national centers, think of those as like specialist centers. They can focus on one specific domain. They get a lot of practice at that domain. They have a big national, and sometimes international scope. So they always have the big picture in mind, and they focus on the science of their specific area. So they partner with the local offices to provide the services that we do. Next slide. I already talked about the test bed, so we're going to skip over to the next slide. So we have a lot of international activities. Certainly, we have an international liaison role to the WMO. We're one of 8 worldwide meteorological centers sponsored by the WMO. So the Climate Prediction Center, we provide flood and drought outlooks for Africa and Central America, the Caribbean, Central Asia as well. Our Weather Prediction Center has an international desk that's focused primarily on the Western Hemisphere. The National Hurricane Center supports countries in our Atlantic Basin and with their regional specialized meteorological center. Our Aviation Weather Center, the Ocean Prediction Center, and the Space Weather Prediction Center, they support like international standards with our international partners. And our Aviation Center is designated as a World Area Forecast Center from the ICAO. It's the International Civil Aviation Authority. That's one of 2 global centers. Our friends from the Met Office, I believe are here in the building somewhere else today, are the other center. We collaborate with them. And then similarly, our Space Weather Prediction Center is also a WMO Space Weather Center and one of 3 global centers, along with the Met Office and then one in Asia. Next slide.
One thing missing is, sorry.
Yeah.
Monsoon desk at EMC.
Yeah, the monsoon, yes. So we need
This year.
yeah, so that's an old slide, so we need to make sure we get that on there. Thank you, VJ. So here are our 9 centers again. So I won't belabor this. We'll just get to each of them one at a time. So next slide, please. So we'll start with EMC because we have VJ here, and we just had a lot of talks with HAFS, or Hurricane Analysis and Forecast System. So I'll talk a little bit more about EMC than the other ones. But I'll try not to make this an EMC talk. It's an INSAP-wide talk. So of course, like you all do here, we provide model products and predictions all the way from nowcasting on this time scale of minutes out to seasonal forecast, which takes us out to about a year, and all those time scales in between. And of course, we have different physics and different resolutions and different time periods of models to support all those different types of products and capabilities on the right, and as well as the different domains you see at the bottom. Next slide. So one of our big effort, as I'm sure you've heard of, is our unified forecast system. So we're really leading our effort really to create this unified forecast system. It's a little different than the unified model for the UK. At least we're starting just right from the beginning to build a coupled Earth system framework. And of course, that's what is evolving to. So we didn't make that first step like they did a long time ago. But we're now moving everything into a consolidated, almost all of our models into a consolidated Earth system framework. It's built around the dynamic core of the finite volume cube sphere, FB3. We're working on improved physics, as well as improved data assimilation, particularly through the Joint Center for Satellite Data Assimilation, or JEDI, which you all here is a partner are familiar with. And we're hoping to build this as an open community-based research and development framework. We're wanting our partners both in the United States and internationally we're trying to build this system to make it conducive for you all to use it for research and testing. So I won't go into all. You can see all the different models at the bottom there that we're bringing into this framework. And we've already had some early successes. The GFS is already there. Our recent HAFS implementation is now our hurricane analysis and forecast system is brought into this framework. We're working on GEFS and CFS next. Next slide. So I'll talk just a little bit about this. And when we get to the end, if you've got any questions about the modeling, it's good. I've got Avichal and DJ here. They're the experts. So the next version for the global forecast system, which is going to be version 17, and the GEFS version 13, will be a fully coupled system for medium range and out to subseasonal predictions. We're using MOM6 for ocean, SEIS for sea ice or cryosphere, WaveWatch 3 for waves, GoCart for the aerosols. So all of these are brought together under an Earth system framework. And the next big version of the next replacement of the climate forecast system version 2, which has been around for a lot longer than we would like it to be. We are pivoting now to seasonal forecast system version 1, and we expect that to be ready to go in about 3 years. That's also going to be fully coupled Earth system model and the similar physics and on the same UFS framework that we have our GFS and GEFS. Next slide. So this is just sort of a simulation that was done at a high resolution of our 6-way coupled system. That's going to be the backbone for all of those global systems, the GFS, the ensemble, the GEFS, and of course the seasonal forecast system. Next slide. So we'll talk just very briefly about some of those components. The GEFS is really, it's going to be our first NCEP, our first fully coupled global ensemble forecast. I'm not going to get into all the details. You can just see we're increasing resolution, we're upgrading the physics, and we've already demonstrated through our early testing really a good improvement on our anomaly correlation. You can see that there on the right. So we're not done in development yet, but we're already seeing the benefits of fully coupled, particularly in the longer forecast days. Next slide. The seasonal forecast system, or SFS, is going to be replaced with CFS. Our goals there are very similar, and really it's going to be, we're going to enable it to run in the cloud. That's really one of the important things we can do so that we can, on demand, when we have to do reanalysis and reforecast, we don't have to procure all the HPC needed to do that. We can surge to do the reanalysis, reforecast when we need to. We're going to be incorporating all the things that here with all the other UFS, and just like the GFS and the GEFS, this is going to be provided to the community, the global community. So that includes our friends here in India. If you want to be able to use it for potentially operations, but definitely for research and development through this Earth Prediction Innovation Center, which has been around for just a few years, and we're continuing to grow that community platform. Next slide. All right, we're going to shift gears here and talk about HAFS. That's one of the reasons that some of us in this room, VJ in particular, with Avichal and another crew that's still back doing some training with your scientists here, as well as some of our friends from Taiwan are here for that. This hurricane analysis and forecast system, or HAFS version 1, was implemented last year. And it was our first fully coupled UFS application that we brought into operations. And of course, that's being designed to replace the HWRF and the HMON. And already at the first version, we were able to really demonstrate about a 15% improvement over the legacy HWRF. Next slide. Next version 2, we just implemented it this year, just in time for the hurricane season in the US. It's really improved science, higher resolution, better vortex initialization, data simulation as well. Bringing in the MOM6 ocean model for the first time in this coupled system. So really a lot of improvements. We've seen some of these cases. I can't see the bottom one, but these are just examples of hurricanes. Which one is that?
I think Hurricane Lee.
It's Lee, yeah. That has really improved not only the track, but the intensity forecast. And it's helped us over the last 10 years through our HFIP, or Hurricane Forecast and Improvement Program, first with HWRF and now with this, is that our ability to to improve on storm track was getting better a little bit every year, but for a long time, our intensity forecasts were not improving. So these new models, first HWRF and now this, are really enabling us to have very accurate predictions of rapid intensification several days before it happens. And we are having organizations or states in the United States, whether it's state of Florida or cities, they're using our 4 and 5 day forecast to actually order evacuations and preparations before sometimes the storm is even formed yet. That's how confident that they are getting it based on the accuracy that these models have given us. It's really exciting. We're really excited to work on this with you here to help you do the same types of things in the Indian Ocean that we're trying to do in the Atlantic and the East Pacific. Next slide. And just a few more examples. I'm not really going to speak to that. Just a couple of examples. You can see that not just within the U.S. but in Asia as well. Next slide. And this is the slide I mentioned. This is why some of us are here. In fact, right now, some of those folks, instead of listening to me, they're actually learning how to use HAFs back at the facility, Prasad. So that's okay. You don't have to go back. All right, we're shifting gears now to the Climate Prediction Center. This is really not really long-term climate. This is a seasonal to sub-seasonal time scale. So we do outlooks from 2 weeks to a year. Every product we do here is probabilistic, and it's based on departure from climatological norms, you know, within seasonal average, above or below, depending on how it goes. We provide some week 2 hazard outlooks, including for the tropics. And so that's collaborating with one of our other centers, the Weather Prediction Center. So they're using those probabilistic and other kind of evaluation techniques for the long range, for seasonal scales, and collaborating with our Weather Prediction Center for like medium range forecasting and kind of working in that overlap in the week 2, week 3 period. They also issue our INSO watch advisory. Inside the U.S., we have what's called U.S. Drought Monitor, and it helps provide a drought outlook, which is updated frequently during the year. That's a collaboration with multiple federal agencies and universities, and they themselves have an international desk, particularly with their partners in Africa. Next slide. So the Ocean Prediction Center and the new deputy director is sitting right here, Avichal Mehra. They provide marine weather forecasts. So they're not really predicting ocean state, they're predicting weather over the ocean, so marine weather. And they're providing those decision support services to their partners, a lot of which is the commercial shipping industry. So tankers and container ships coming between Asia and the United States and Europe and the United States, they come over the Atlantic and the Pacific. And so a lot of our products are there to support that shipping. They have a lot of, they do outlooks up to 5 days, they do warnings and advisories for winds and high seas, and a lot of graphical products. And they have a component inside of it, and I'll show you the next slide, please. A special office called the National Ice Center. That's a collaboration between ourselves at NOAA and NCEP with the U.S. Navy, and they're interested in the Arctic, the North, as well as the U.S. Coast Guard. And so this is a cryosphere-based, or it's a really small group, and they do analysis and short-term predictions of the formation and movement of ice in the polar regions. And that's also primarily for shipping. Next slide. So the Weather Prediction Center, it's kind of a boring name. Everything's weather, right? But this one, think about this one as high impact weather. And so the big 3 areas that they focus on are big rain events that can produce flooding, big winter storms, and then temperature extremes, whether it's heat waves or cold outbreaks. And so this is the one that's probably the busiest during the year because there's always something happening somewhere in North America, whether it's it's a drought somewhere or a heat wave or a snowstorm or a rain event. They're focusing on the big national picture, and they don't have a downtime or a season like the hurricane season has. So this is kind of the nerve center of really working with a lot of our local offices. Next slide. So the Storm Prediction Center is really our experts for tornadoes and severe weather. So everything they do is also calibrated probabilistic products, and they do risks for severe weather. And so they have a lot of mesoscale expertise, particularly on convection, and not just severe weather, but of course the severest of all, tornadoes. They have a small group also that also focuses on fire weather, particularly in the U.S. western side, where most of our fires occur. And they provide primarily weather watches for the next day or 2 or 3 days. And they've gotten better too than extending their forecast out by an extra day or 2. And the crossover with the local offices, when it gets within like 1 day, and there's going to be an actual tornado they see on radar, our local offices do that. The bigger picture and the longer range forecast is done by this center. Next slide. The National Hurricane Center is just what it sounds like. They focus on all the hurricanes that happen and hitting the U.S. continental United States. So most of them, of course, from the Atlantic and some in the Eastern Pacific. They also have an interesting, they're similar to the Ocean Prediction Center. While they're watching the tropics for hurricanes, they also provide marine weather products for the tropics as well. Professor Dube was just here. If he was still around, I would talk to him a little bit about our storm surge capability. That has been our biggest improvement at National Hurricane Center over the last 10 years. I think that is the largest scientific improvement we've had for reducing the loss of life on the coasts of the U.S. Our capabilities have increased, our accuracy has increased, and then our ability to communicate it has gotten better. So we have similar situations where major tornado hurricanes hit. We have very little loss of life at the coast. It's kind of a combination of this better modeling. There's also the people at the coast are used to this. They understand what to do. So often our biggest loss of life in big tornadoes happen 2 ways. One, it either happens after the fact during cleanup, where people have heart attacks, or they die because the power's out and they can't get to the hospital. And some, they use generators too close to the house and die of carbon monoxide poisoning. All of these are greater numbers of deaths than the storm itself. But the exception is inland. We've definitely seen areas tens, if not hundreds of miles or kilometers away from the coast that are not used to hurricanes. And they can produce these really huge rains they don't normally see. And particularly in areas of complex terrain, it can create flooding that they've never seen before. So we're putting a lot of effort into our messaging and social science to be able to help communicate the risks. Because unlike the people at the coast who know what a hurricane is, they know what it looks like, they know what to do, it can produce these inland rains that our population just doesn't understand. It has very, very unique circumstances. And we had one of these such disasters just a few weeks ago in North Carolina, an old town called Asheville, which incidentally has our National Center for Environmental Information, part of NOAA, at that site. That building was okay, but many people in the surrounding areas lost their life due to flooding. Next slide. So our Aviation Weather Center, AWC, is located in Kansas City. By the way, I did fail to mention the last 2, Hurricane Center and Storm Prediction Center, are in different cities. They're not in Maryland. This one is also in Kansas City, Missouri. It's a different place. They really talk about the big national picture for aviation. So they focus over the Atlantic, the Pacific, and over the continental United States for things like convection, clouds and visibility, icing and turbulence, and other things that can affect flights. It isn't necessarily water-based meteorology, things like volcanic ash and dust and sand. There is a special Alaska weather unit that's up in the top left. They have a separate office because up in Alaska, there are almost no roads. So you have a lot of small planes flying around between towns. And they have complex terrain up there, and the infrastructure is not very good. So it's very rural. So we have specialized support up there. So it looks a little different than our other one. So that's why I have a separate office. And then the Hawaii forecast office looks specifically in areas of the Pacific that are affected by the U.S., such as Hawaii, Guam, and American Samoa. Next slide. Our last center has the word weather in it, but it's really not weather. The Space Weather Prediction Center in Colorado is really monitors the sun and puts out alerts, mostly nowcasting for things like geomagnetic storms, which is magnetic field disturbances, plasma that's ejected off the sun that can really interfere with and induce currents in the U.S. And across the world. There's also radiation storms. And finally, electromagnetic radiation can also affect radio blackouts. So this has become and really increased importance over the last several years as we've become more dependent on technology like GPS. So we've seen the impacts. There's a lot more technology to be affected. I mean, it's not like the sun is getting more dangerous, just that the impacts are growing because more things we have are impacted by radiation and induced currents. The biggest problem, the biggest worry we have is the electric grid. A large enough magnetic storm could induce currents and blow up, could cause transformers to fail and bring down parts of the electric grid, which is a huge national security and economic threat. So that is only the biggest storms can do that. We saw one this year that we helped talk to the power industry. We did that decision support service with them. Based on our analysis and our alerts, they were able to do mitigation so that we didn't have blackouts. So this is one of the problems is that when a big storm happens and there's no impact, people think, well, this is not a threat. What they don't see is all the mitigation that happens behind the scenes. Next slide. And finally, our last center is INSEP Central Operations. This center is our IT infrastructure. It started off just as INSEP Central Operations. And so it was really our IT infrastructure just for INSEP. Over the years, it's taken on the infrastructure for the whole weather service. So because of that, they're going to change their name. They're going to keep it NCO, but the N is going to become National Weather Service. And they're going to leave INSEP and move to the headquarters. But it's going to reflect the things that they're doing for all of the weather service. But they're still part of INSEP for now. One of the things that they do is they work on our operational supercomputer. We don't have it in our facilities anymore. We pay for it, and it's housed in private data centers. So we have a primary and a backup. They're geographically separated in case there's a disaster, different power, you name it. And so we do research and development and testing on the backup, while the other one's in operations, and we swap them back and forth at times. They also have dissemination hardware in our building, and we have a backup site in Boulder, Colorado. So we're trying to build up our dissemination infrastructure to have a primary and a backup as well. They manage our web internet presence. A lot of our websites are on weather.gov. You can find them there. And they also manage the network for some of our local offices. They connect our local offices. So they have a big role, but they're the only one that really, they have very few, if any, meteorologists here. These are really IT professionals that really take care of us, and they're the backbone of the processing and dissemination parts of our mission. Next slide. The last one is not an INSEP center yet, but that's changing. We have 2 tsunami warning centers. One is in Alaska and the other one's in Hawaii. They were both formed in the 70s after major tsunamis that happened without warning. And so, and that's, I think a lot of the world tsunami centers got stood up after a disaster, and they realized we need to do a better job. We have 2 centers, like I said, one's Alaska, one's in Hawaii. They were formed at different times. They had different scientific approaches. They have different IT systems. They do everything differently. So because of that, they really have a hard time collaborating. They don't have the capability to back each other up. So it's not a good situation. So we are building a new organization that will take both of those centers, give them new workflows. They're going to work on a joint operational workflow, and they're going to get new systems that are the same. And together they're going to combine. They're still going to stay in 2 locations, but they're going to combine to be the next INSEP center. So I'm really excited about that. That probably, we're already starting the process. The formality of making them formally a center it involves money and politics and notifications to Congress. that probably won't happen for a year or two, but we're already on our way. Next slide. So that's kind of how, all about the Weather Service and NOAA, what our big pictures are and how the INSEP fits in. So I want to talk to you at the last slide. There's a lot on here. And I'm hoping that maybe we can have a conversation from here, what's happening on your side. So I'll just tell you, these are in no particular order. I just threw these together yesterday, things I'd like to talk to you about. I mentioned that our new director at the Weather Service is wanting to transform and modernize our, so we're not just modernizing our infrastructure, but also our business processes, our operational processes. So we are restructuring our forecast process so that we can be more efficient. Maybe instead of needing 122 offices that are 24/7, maybe fewer of them can be 24/7. Some can be bigger, and some can be smaller. We can take some of those people that are not doing shift work and put them in our partner agencies, and so they can really interact with them more frequently, so we can have a better impact on decision support. But doing that is a challenge because we're not getting any extra money to do it. So we have, like I know that you all have here, often we have a flat budget. So it's better than being cut, but it's not the same as maintaining capability because it doesn't keep up with inflation. So that's a big challenge for us, is that we're having a hard time keeping up with inflation. All our costs are going up. So we have to do things a little differently to be able to not just survive, but get better. One of the things that we're doing is, all of our business processes that from our major customers have traditionally been deterministic. We're with ensembles and all the other statistical techniques, we are really pushing to move all of our forecasting into probabilistic space, not just long range climate or the seasonal forecasts or outlooks out to the week, or even short range. We're trying to shift to probabilistic. Now, that's good for us as scientists. I don't know that our partners or the public are ready for that yet. So we're putting also a big effort to work with our key partners to make sure that what we provide them still meets their needs and actually helps improve their operations. But there's also a big outreach effort with the public to try to educate them on how to listen to and understand our probabilistic forecast. So it's a big challenge. So we are investing in social scientists, not just economists, but actual behavioral scientists to help us build products that normal non-science people can understand and also interpret appropriately, because we don't want them to misinterpret and do the opposite of what we're trying to convey. A big challenge we have is competition with the private sector. When I came into meteorology back in the 1980s, the only place to be a meteorologist for the most part was in the National Weather Service or with the Department of Defense, with the Air Force and the Navy, and or on TV. There were a few companies that had but not very many that had meteorologists. Over the last 20 years, explosion of uses for earth scientists, not just with private weather companies, but they've embedded earth scientists into financial institutions, insurance companies, a power industry, a lot of these places. So we have to compete to get the best scientists and engineers with all the private sector. And there's two things the private sector does better than us in the government. One, they pay better. And two, they're less bureaucratic. So it's easier to get things done. So that competition is not just for scientists, but particularly for, I know you all are dealing with this too, with IT professionals, private industry. Google pays a lot more. So being able to do that, we have to really build programs that can not just go buy, hire people, but retain them as well. So that's a big challenge that we have that we're struggling with, and we'd like to talk to you about that. There's actually one thing we're doing with the Met Office. I met with Stephen Belcher when I was chief scientist for weather at the Air Force. I met with him a few years ago. We had this conversation. We realized that, hey, neither one of us there's not enough data assimilation scientists. And we realized we were actually hiring from each other. It's like, hey, I just got this great scientist. Hey guys, I know you stole him from me. So what can we do to build the global population? So right now it's a pilot program between the US and the UK. I really feel that we need to expand that. And so that's something that I'd like to talk to you all about soon. That's just one area for data assimilation, but we're also talking data scientists that are, can we attract and retain machine learning or artificial intelligence folks that can help us build our capability. That's a big challenge, and we're trying to work on that together, and we'd like to work on that with you too. We have a lot of experience with machine learning and AI for modeling, whether it's neural networks that we started working in EMC 20 years ago. Right now, we're doing things with model emulators in the UFS. So that part, I think that we know kind of what we're doing. We're exploring a lot of that. However, all the other applications, whether it's forecaster tools, how we interact with data, there's lots of AI applications that are possible. We don't have a plan inside NOAA, the Weather Service. It's just things are moving too fast. And I know that all of our global partners are struggling with the same thing. So this is also an area of collaboration I think that would be interesting for us to talk about. We've had a long area of collaboration on data exchange, collaboration on, as we talked about for 30 years with modeling. I think maybe we need to be looking, how can we collaborate on how are we as meteorologists and oceanographers and earth scientists going to make use of machine learning and AI, not just for modeling, but also or research, but for operations and for other uses. The next challenge we have is we're continuing to progress with EMC in particular on building and our NOAA lab partners building our unified forecast system or UFS. But we have limited budgets, so that's a problem. We also don't really have focus agreement across the U.S. We're the only federal agency that's using this UFS. NASA, our Defense, Navy, and Air Force, NCAR, they all have their own models. So we are still fragmented in the U.S. So it's a challenge for us. How do we get more partners for our UFS? I'm really envious, and I think what the Met Office and the partners like India here have done with the unified model, that kind of global consortium is something that we want to build for UFS. We just haven't gotten there yet. So we want to lower the barriers for use of UFS, make it easier for researchers and partners. But so far, we're the only federal agency, so that's holding us back, I think. So I'm really interested to hear your challenges for collaborations with your own modeling. I mean, I'm sure you don't have any problem. I'm sure IMD and NCWCRP, all of you all use the same models. I'm joking, right? We have the same problem in the US. We have different agencies or offices doing different things. Can we go back one? There you go. And finally, this is a broad area, but once we improve our prediction, how do we make use of that best to best impact society? So one, we have to demonstrate the economic value. That'll be helpful for us getting money from our federal government, to show that we're a good investment, that we can, for every dollar that comes in, we can provide benefit to the public and society, and not just for weather, but for other things. We are investing some in, like I said, economists and other social scientists to help us show that. But there's also being able to make sure that our environmental predictions are understood, and we can communicate them effectively, both verbally on TV and radio, and help our partners do that, but through the web, through automated products, for visualizations, both static images and video, and then even foreign language. I mean, we have there's immigration everywhere. U.S. over the last 30 years, we've traditionally in the U.S. a lot of our immigration has been from on the West Coast from Asia and the South from Latin America. But we've had an explosion of migration from everywhere in the world, particularly for India and China and other places coming not only to study in the U.S. but for moving there. So many languages are coming in, but we're a single language country when it comes to official products. So our weather ready nation concept is we want everybody to be safe. So putting something out in English made sense 30 years ago, maybe. not anymore. So we are making use of machine learning AI to actually help translate our products into multiple languages. So we've started with 2 or 3. Spanish was our first one because that's our second language in the U.S. But we're trying to get that across multiple languages. And it's not, we've learned that it's not just a simple dictionary translation. There's dialects, there's phrases that can confuse people. So we really want to make sure that we put out a product that talks about threats from flooding, that people understand it and know what to do. And so that's a big challenge for us too. So this is just a subset of all the things we're looking at for the future and the challenges that we have and we're dealing with. That's kind of my last slide. You can go to the last one, but this is really the last slide of substance. So that's kind of all we're working on. And I really, I'll end where I started, to thank our new friends here, Dr. Prasad, Dr. Mohapatra. Thank you so much for hosting us. It's my honor to be here, and I look forward to hearing your questions. Thank you.
Yes, it has been an excellent presentation by Dr. Farrar, and you have not only covered the evolution of the NSAFE, but also you have covered the future. In India, we are moving towards 100 years of independence, towards 2047. And here, this period is called as Amrit Kal. Amrit Kal means it is the auspicious period, which has started starting from 15th August 2 years back. And 15th August is the Independence Day. So certainly your vision and the future plan will help our youngsters and all of us to think high and work accordingly. We are really thankful to you for these presentations and deliberations. Now it is open for everyone for any comments, questions, or suggestions. Yeah, Dr. Soma, you can introduce and then.
Hi, I'm Soma. I'm in the National Weather Forecasting Center.
Okay.
So can you go back one slide, please? I was interested in your last point in the slide. I think US is now going towards the concept of focusing a continuum of environmental threats.
Yes.
Facet. Can you talk a little bit about it?
Yes, the concept of that facets or forecasting a continuum of environment, it was built first upon the tornado and severe weather threat. So the way we've always done business for when it's actually occurring, and we're still doing it that way, is we put a polygon out for a tornado warning, a severe thunderstorm warning, whatever warning it may be for a time period, and it just sits there. The threat moves through, and a lot of our automated messages are sent out to your phone, or even as people communicated on TV based on that polygon. What the part of the problem is, we know that it's going to leave that polygon and go somewhere else. So rather than wait until it's ready to come out and issue another warning, and it's just this discontinuous jump, one of the products we're looking at is trying to make it more continuous and dynamic. And as the storm evolves and the threat moves, to move and not just move a static polygon, but maybe actually change its shape and have it vect with the threat. That would make it easier for those automated situations. So you'd get an alert on your phone earlier. It also allows, if things evolve, you can come off. You can have your alert canceled. In other words, you're no longer in the threat. So sometimes what will happen is you'll take cover if you're on the western side, as it moves from west to east, you're on the western side of that polygon, but it'd be, the threat's over an hour sometimes before they lift and they cancel it. So it has a lot of negative impacts. People will sometimes take risks they shouldn't take. So that's the concept. I think they want to use it for other threats other than just severe weather. So there's a lot of software development that's going on there. And then there's also, it's not universally accepted yet by our partners. This is our idea. Our partners understand the concept, But until we can have demonstrate these tools work and we don't break some kind of linkage, it's going to take a while for us to get there. Thank you.
I have one question. You are the right person to answer this question.
I hope so.
So you are from the Air Force, although you are from the
I was with the Air Force, yeah.
NMC also.
Yeah.
And the Air Force is co-partner with us in the UM partnership.
Yes, they are.
Using that one.
Yes.
What is the reason why Air Force is taking different step from the ANSEP? And you are in both the places.
Yeah, actually, there's an official reason and I'm not supposed to tell you a reason, but I'll tell you anyway. All right, so both of them are true. So first of all, I was with the Air Force back in like I said, I joined in the 80s, but in the early 90s, the Air Force models had atrophied. The Air Force and the Navy and NSEP were all in one office together called the Joint Numerical Weather Prediction Unit back in the 1960s, I believe, or 70s. And then at some point they split. So we were all that was the glory years of early where we were all working together. Well, then as it progressed, we all had our different functions and we split. So the Air Force continued to do their own models, but they couldn't keep up with the Weather Service or these other places. They kept getting, if you show those charts for those correlation charts, the gap kept getting bigger. And so at one point during the 1980s, during President Reagan's time, a lot of money was being put into Star Wars, and so they were grabbing money everywhere. They basically just looked at us and said, your models are terrible. Just go use somebody else's model and we're going to take your money. So that's what happened. So first we started, for the global model, we used the Navy's model. And then we the Air Force. Thank you.
Your view is confusing.
Yeah. So all of this is from the Air Force perspective. Okay? So we in the Air Force, I still feel it. Yeah. It's okay, but thank you. So the global model, originally we used the Navy, and then the regional model, we had our own. It was we got rid of that and we partnered with NCAR, with MM5, and then WRF. And I was involved in bringing WRF on. Over time, the Navy's model, also the gap was growing, and the Air Force said we're going to use NSEP's model. So the GFS became their primary system. So the Air Force they ended up bringing MM5 and WRF into, that's what the Air Force ran. They didn't run a global model. So about 5 or 10 years ago, the requirements of global things we were working on, as well as there's a lot of reasons, but they decided that they wanted to run their own global model again. And so they looked at all the possibilities and they decided to partner with a key ally, which is, in NATO, one of the key allies was the Met, the Met Office. It was also cheaper. And you could buy into the consortium and it didn't cost a lot. And then all they had to do is they had to get their own supercomputer again, but they took that model. And so the Met Office was used to running this partnership. We don't know how to do that. We've never done that before. I'm sorry. NOAA never did that before. They didn't partner well. So this is before the UFS. So it was a good decision. It's really worked well for the Air Force. So maybe in the future, when the UFS is better and more mature and they have a partnership, maybe the Air Force will come back. Now, the part that it's unofficial that I'm not supposed to tell you is there was actually an initiative in the Pentagon. And basically it was the Brits are buying a lot of stuff from us because we're going to give you money to go buy stuff from them. So my old boss said, well, it made it easy because he didn't even have to pay for it. He wrote a proposal, he set it up, and then we got the money to go pay the Met Office. So we, the Air Force. So anyway, that's a long story, but the bottom line was the partnership has really served the Air Force well. It's enabled us to get closer to some of our other allies, with Australia, for example, for some of our concerns in the West Pacific, as you know what I'm talking about. So anyway, that's how it worked.
So just
Right.
yeah. So I'm Dr. D.R. Patnaik. I'm at present working in heading the modeling division and also the cyclone forecasting. So looking at the first slide where you are showing the mission, it is just similar to the mission of IMD also.
Hmm.
And my question is that as we understand the private agencies are actively involved in USA, particularly this thing. So to achieve your mission, what is the present level of engagement of private player to achieve this mission of your organization?
That's a good question. I'll answer. There's two pieces of that. So maybe I misunderstood, but I'll talk first of all that we kind of have a unofficial understanding in the U.S. between private industry and the government. There was a lot of competition, and some of the private companies would complain to Congress that, hey, they're taking business away from us. So back in the 90s, there was the American Meteorological Society helped broker a few colloquium. They had workshops, and in the end, they kind of figured out the best thing to do was that the National Weather Service, they retained ownership of safety with the public. Private companies, they shouldn't be speaking for the government for the safety of the populace. They also spent a lot more. The government kind of owns the special support partnership with the aviation, with the FAA, also a government agency. And then there is this other government agency support that we're partnered with. But for specific industries, like if you want to have support to the renewable energy sector or private shipping, some of those things, or building applications to like building phone apps, that was kind of determined, that's the private sector's, so they would go do that. So we've had a kind of a truce over the last 20 years where we kind of know what our role is and what their role is. So that's part of the first part of the question. The other part I think you were asking is, what does private sector do to support?
Yes.
Yeah. So there are some places that boundary is not clean. It's kind of a fuzzy area. So they're just like we are trying to do decision support services to like the state and local emergency managers. Some of the local offices, they go out and hire their own meteorologists from a company because the weather service doesn't have enough people to send a forecaster everywhere.
Okay.
So there is some local government support that they will go hire. They will go hire their own meteorologist. And then the biggest part of the private sector, we have contractors. So whether it's the central operations for INCEP that has the computers, or in Vijay and Avichal's case with EMC, our modeling center, they have 50 federal employees, but they have 150 contractors. That's a private company, but that's a special relationship because we put a bid out to come work for us and do what we want them to do. So there's no competition. They're just part of our bigger team. So that contracting role where we put a contract out and companies come in and help us, that's a very specific thing. Well, that really, there's no competition there. One of the interesting things you'll see if you go Google it is that there was something with the Trump administration. There was this big report called Project 2025. It was some of the think tanks, the right-wing think tanks. There was a little section there about weather, and there was a desire to have the private sector do more.
Oh.
And it maybe take mission away from NOAA. That's just somebody's opinion, but that's been talked about before. So this will be interesting over the starting next year. Whether we don't know whether or not that's going to be a priority of the new administration. The last time it was talked about, both political parties, usually two parties in our country, they were both against it because it would interfere with public safety. So there are some red lines that even our politicians don't want to cross when it comes to public safety, because there's tornadoes that happen in districts where you have one party and districts with the other party. Weather's everywhere.
Yeah.
So we've been pretty well blessed by being supported by all of the political spectrum. But we'll see whether or not that changes next year.
Yeah. So that is partly they are contributing complementary, not the contradictory stand.
That's correct.
Yes.
But there are times where we do conflict, and we try to work it out. Sometimes even when we were updating our website, and it's easier for people to go in and get to plug their zip code in, we had all kinds of uproar from some of these companies. It's like, I just lost business because they don't have to come to my app anymore. They can just go to your website. So there's nothing we can do about that, but we try to minimize that. That's kind of where the conflicts are.
Thank you.
Sir.
I have a question.
Yeah, Dr. Anand.
Thank you very much for a nice talk. My question is related to IDSS, Impact-Based Decision Support Service. How effectively you are doing it, because it involves the social expertise from the social science. So how NSEP is taking care of that?
Yeah, there's several ways we're doing that. So I mentioned the test beds at the centers. When we have new products or services, sometimes we will bring in social scientists, bring in our partners, have our own forecasters and our scientific developers all together. And we'll go through scenarios together in these experiments. And we'll have social science experts there to help us. So that's one way that we can bring the social science in to make our IDSS more effective. Then there's just something simple, like if we put out a new product, we will sometimes contract or use our own internal social scientists to help us design a new product, whether it's which color schemes to pick, which words to use. They can bring their social science expertise that they've learned from years of research, as well as through surveys and focus groups. We do a lot of that too.
Yes.
This is Madhulata. Thank you very much for interesting talk. You covered all units also. From your presentation, I have seen increasing the cloud services. In your future perspectives, you showed next radar and cloud services. So what it exactly is what you are going to do in that?
Sure. But you said radar and the cloud services?
Yes.
Yeah. So I did talk about radar. I'll talk a bit more, but our biggest challenge with radar is we have a very old network. So our NextRad Doppler radar network was installed in the early 1990s. It's over 30 years old now. And we've done service life extensions. We go replace parts, but the whole structure can't be, upgraded or maintained forever. So we're now in the position that we're going to have to replace the whole network in the next 10, 15 years. So we're starting a big major project now. We did get money from Congress to go do a study, to do some of the engineering work, to build the case so we can go back and ask for that. I think that one, even though it's big money, it has to be done. So I think we're going to get that done. But it's more than just taking 122 radars and putting 122 back in the same place. Part of this is that network wasn't perfect. It had spots where it wasn't sampled very well. Originally, we tried to maximize the population, so sometimes we miss rural areas, and so that leaves some of those populations vulnerable. Other times it's there may be some other reasons why it doesn't work as well. So we have gaps sometimes in actually important areas. There's some cities that have a shadow from terrain shadow. And then there's just, sometimes just the natural curvature of the earth. I mean, you can even though you can get some coverage in some areas, you kind of miss shallow precipitation. So when we do this next generation, we're going to try to do a combination of 2 or 3 things. Big radars to replace the old ones, smaller gap filler radars in the middle, and either we'll buy them ourselves or we're private industry starting to build them and trying to sell the data. So that's going to be part of this new, maybe a hybrid mix of private sector having their own small radars, selling us the data, or we buy them from them. And then finally, there's a little bit of, can we incorporate other data types to meet, like for radar, you want to be able to detect tornadoes or hail or rain. There are other sensors that can do that from satellite, there may be artificial intelligence algorithms that can help do this. We may build that into that radar program. So that's about it for the radar. For the cloud services, there's a lot there. I don't have time to talk about it all, but a lot of our operational systems are on legacy hardware that sit in the office. You have a big rack of equipment. It's expensive to maintain. It goes out of warranty. You have to keep replacing it. So all the local offices, we want to replace all those, on-premises hardware with cloud technology. So that's going to take, we got to do a lot of refactoring of the software and even with some of the hardware interfaces to be able to make it work in the cloud. And that's disseminating data that's produced locally, like the radar. And there's also things that all those local systems are even connected to our weather radio, which puts out alerts. It's connected to notifications. So some of those things are like old copper lines. We're going to replace all that too. So all the local office stuff is going to go to cloud. Our model output, how we do processing, we have different post-processing at some of our INSEP centers. We want to move those to cloud as well. And then in the end, we're going to explore our supercomputing for models. I don't think that it's not in our short-term plans to try to run all of our models in cloud. I think we're going to explore that in the future. I know the Met Office had a really nice solution. They hired Microsoft to just let them figure it out. It's like, you give us cloud, here's our requirements. You tell us which part should be in cloud and which part should be our own HPC. That's going to be a big project for us for at least the next 5 years, at least, maybe longer.
So if time permits, I have one quick question to you. Sir, you mentioned so many units from weather to climate, and you have operational center also there. So the question is, whatever research done on different aspect, like different units, what is the physical or working mechanism you follow for converting or transitioning your research to operations?
Yeah.
What you follow there?
Yeah, that's really good. We have most of our centers have a research partner in NOAA. So at one of the very first slides, I showed those 6 boxes inside NOAA. Weather Service was one of them. One of them was the Office of Oceanic and Atmospheric Research. That includes research programs and also 10 research labs. So we have a lot of partners there that do research in our area. So I'll give you an example. The Storm Prediction Center in Oklahoma, they have the National Severe Storm Lab. They're in the same building. They work together. Other ones, it's not so clean, like with EMC, Environmental Modeling Center, 2 or 3 of the research labs are doing model research. They're in different places, but they work with us and they help us transition. They work on kind of like Gopal, for example, is a good example. His group down at the Hurricane Research Division, they help us develop new models. So that's more of applied research, but they also just do scientific studies for understanding. So they work with the Hurricane Center as well as EMC for things like that. We don't have a research partner for the space weather. So there's nobody in NOAA research that does that. So we partner with NASA and academia for that. Does that answer your question, or is there more to it?
I just asked how you are following the working mechanism for transitioning the new research, whatever you get, how you are using it into operations for any severe weather or seasonal wise also. How you are transitioning your research to operations. What is the working mechanism you follow at NCEP? Because you have,
the unified forecast system that we have has a mechanism to entertain research that done on the same framework. And the R2O, there is a project specially designed to transition the research from any place, whether it's academic institute or NOAA lab or international conference. They all come through open source, open development, and the testing and evaluation is done through the test beds that Mike mentioned.
yes.
So those are the mechanisms that we use for R2O.
Thank you, sir.
Thanks. Thank you, Vijay.
I have a question. Hi, I'm Suman and I'm working in GIS application development. My question is, in your opinion, what do you think that which weather phenomena is still difficult to capture in US, and what is the research gap and how it can be? Is there any?
Well, I think about that for a minute. I think probably I'm going to talk more from an impact perspective rather than just a science perspective. I think the ones we are doing a really good job at improving hurricane forecasting, for example, and it's having a really big impact on our loss of, reducing loss of life, just like you're doing here in India. I think one of the areas that is a challenge for us is, and it's not even it's not contained within INSEP. Remember that other center I told you about, the National Water Center? I think the flooding in compact the flooding problem, particularly in complex terrain, is something that is a challenge for us. Being able to, we don't have the high performance computing to be able to run a really high resolution stream flow and hydrological model and ensemble mode, which we probably are going to need to do something like that to be able to really demonstrate the risk of flooding in a certain area. Also, those kind of things are so random. It appears to be random that people can live there for 30 years and never see anything. And then you get the right rain at the right place at the right time, and then they can be inundated, and they have no context for understanding what the threat is or what to do. So I think that area is probably our biggest challenge that we're working on.
And all other weather phenomena are well captured and well predicted and well.
Oh, I wouldn't say that. But I'm saying, you asked me which one was the
Yeah,
one, that's the one that.
weather phenomena which is difficult to capture still.
We have a lot of them, I'm sure.
Okay.
But that's the one actually that has the biggest impact that we need to address. But we're still working on, better modeling for marine weather, for, space weather is a huge one. Because we are like 50 years behind traditional meteorology. So it's like the 1950s in terms of ability to predict a future space weather event. You have similar, I think all the centers with other, with whatever discipline they have, they're all trying to increase the prediction in their system. So, but at least the one I gave you, I think that's the one that I think is having the biggest impact on life and property in the U.S.
Yeah, Priti.
Good evening, sir. Thank you very much for giving such an informative talk. So, one question is, can we use space weather prediction for climate prediction in any way?
I'm sorry, say it again.
So, can we utilize space weather prediction for climate forecast?
I mean, can we demonstrate that the sun is having an influence on the climate? Is that what is that I'm trying to make sure I understand the question.
Actually, sir, you mentioned that one unit is for spatial dedicated for space weather prediction.
Right.
So can the output of that space weather prediction be utilized for climate prediction somewhere? Nowhere.
No, really, there's not.
Electromagnetic radiation or
No, there's not really a relation.
nowhere. Like orbital, like the planet orbits that has been changing nowadays, like once in 1,000 years.
That isn't space weather, actually. So space weather really is more of the impact of a solar event on the atmosphere. That's really our focus. Yeah, definitely there are long time scale issues of, like you said, orbit, solar output, because a solar constant is not really constant. I mean, there is that, but that's not what we do for space weather. Space weather is really short term. For us, I think the next challenge is to actually do dynamical predictions. We can't do that yet. The science isn't there. What we do is we can see things happening on the sun, and through some modeling and some experience, be able to, is there going to be a flare coming from that solar sunspot area? But we can't predict when the sunspots will appear. That science isn't there yet. So I think there is some early research on trying to predict 2 or 3 days out an event. Right now, it's almost all now casting for space weather.
Okay, thank you, sir.
Sure.
Yeah, Dr. Busser.
The NWP division. So in IMD, we are utilizing NSUP GFS data along with IMD GFS data in our decision support system. So currently we are getting the data in 25 kilometer. So my question is when we can expect high resolution data from NSUP from a public domain.
All right. Well, that one definitely I'm going to defer to my EMC colleague there.
So the native model output is distributed through AWS, not through the FTP.
Through AWS access, we are getting in 25 only.
There are some files that are being distributed at native resolution, particularly the flux files for the surface weather, not the 3D. Want to have full 3D? That's the bandwidth is not enough for you to get it or we to support. So yeah, that's a very good important question. But when we go into the cloud services that Mike was talking about, you may have better chance to get the future operational data in full resolution.
Thank you.
Any online questions?
Online participants may kindly mute and ask their question if they have. There is one question by Bibraj.
Read the question.
Sir, are SSPA based weather radars planned to be a part of upcoming upgradation of radars?
Say that again?
Is asking.
SSPA?
Solid state.
Oh, I understand what you're saying. Well, this is interesting. The National Severe Storms Lab, NSSL, has been experimenting with solid state radars for 20 years. There is some solid state radars, for example, on Navy ships. That was actually they pulled some of those ship radars and actually put them there to experiment with. The ability to have that function the same way in terms of a 360-degree, it's not ready yet. There really has been issues. So I think originally we were thinking we were going to have a solid state radar, and that was the plan. Right now, I believe we're probably going to just announce our requirements and allow industry to resource it with what they think best. So it's very possible that our next generation radar will be a conventional radar and not a solid state, or maybe a combination. So I think that we are losing confidence that we're going to be able to develop that technology inside of NOAA and give it to industry for them to give it back, to sell it back to us at scale. So I know that we're still looking at it, but we're not going to wait. We're not going to wait for that technology to mature. I think our other radars are getting so old. We have to move out sooner rather than later.
Apart from this, sir, he asked solid state power amplifier. Any technology development we are looking into the upgradation of 120 radars? Like phased array kind of a concept.
Yeah, we are. The phased array is what I was talking about. But is there another? If yes, just follow. I didn't quite. If there's another question, I couldn't. You mentioned solid state. I mean, and phased array. The phased array radar is what.
Sir, actually, he asked solid state power amplifier. This is one type of technology upgradation in case of the DWR. Apart from that, any technical technology upgrades like a phased array concept nowadays is coming into the DWR. So that type of upgradations we are looking in the upgraded version of the DWR.
Yeah. Okay.
And any other questions? Anup? Fine. Okay, Dr. Soni.
So let us thank Dr. Michael for very insightful. And now I would request our DGM to kindly felicitate Dr. Farrar with the shawl and a memento.
Oh, thank you. Yeah.
Very nice.
Thank you very much.
Thank you so much.
I also request our DGM to kindly present a memento to Dr. Avichal Mehra. Dr. Avichal Mehra is Chief Coupled Modeling Division, NCEL.
Very nice.
I would again request our DGM to present a memento to Dr. Vijay.
Thank you.
So, a last part of today's function is the vote of thanks. So, I'm honored to present the vote of thanks. We appreciate and thank Dr. Michael R. Farrar for kindly accepting our invitation to deliver this talk. We also thank Dr. Avichal, Dr. Vijay, Dr. V.S. Prasad, Director NCMRWF, for kindly joining this important lecture. We are thankful to our DGM for kindly sparing the time despite of very busy schedule and guiding us in arranging all these 150 years celebration activities. And also thank to all of you, and we look forward to join all of you again in next lecture of this series of 150 years. Thank you all.